back. Let's talk about assessment preparation 9B. Mostly in this one, we're going to be talking about linear equations. So let's talk about some different formulas that have to do with linear equations. My slope, which is going to be my rate of change, is going to be the change in y, or I'm not going to use the letter y here. I'm going to use the term that we've already talked about here. This is my change in my dependent variable. And variable. Make sure that I'm spelling that right. Spelling this not okay. Change in my MTH. I thought it was all E's. Dependent variable over my change in my dependent variable. My independent variable, change in y over change in x. And I'm going to make the thickness here a little thinner. It's too thick for me. It's hard to read that. You're used to calling this rise over run from, and you may think of this as y2 minus y1 over x2 minus x1, or it's better to think of that f of x2 minus f of x1 over x2 minus x1. And I talked about this notation a little bit in the beginning of the last video, what that function notation means. So that's one thing, slope. Couple equations of the line that we have. We're going to have the slope intercept form. And this should be familiar to you because you all should have taken an Algebra 1 course at some point. Y equals mx plus b, where m is the slope and b is the y-intercept. F of 0 is equal to what we call b. Y at x equals 0, or f of 0 is equal to b. So it's going to be that place where it crosses the vertical axis. Another form of the line we have is called the point slope form, and these are named after what you need to build these. You need the slope and the y-intercept here. Point slope form, you need just any generic point and the slope. This can be, and when I use y, I always mean a dependent variable. When I use x, I always mean an independent variable, even if they are different letters. This is going to be y2 minus y1 equals m times x2 minus x1. So this is the change in the dependent variables is equal to the slope times the change in the independent variables. So between those 2 points. So don't get too confused when you read the book throwing in words about dependent and independent variables. If it helps you to say x and y, go ahead and do that. Let's come on over here to my PDF now, and I'm actually going to make this bigger so that I can draw on it. The price of a particular car model is $11,730 today and rises with time at a constant rate. It's going to be important that we're rising at a constant rate here of $1,125 a year. So I'm going to have P of T probably. P for price, T for time. It's going to start off at a base price of $11,730, and I'm going to add $1,125 every year, where T is the number of years that have passed. It wants me to find the price after 3.2 years. So I'm going to say that that's going to be 11,730 plus 1125 times 3.2, calculator time. I'm going to stick that off to the side over here, is going to be 11,730 plus 1125 times, use the asterisk key on your keyboard if you're typing, or use the multiplication sign there. It's going to tell us that the answer here in dollars is 15,330. I need to change that so that that stays on top. View. It does not. Let me do that. It should, but it doesn't. Okay. So let's see if it's down here. It's not. All right. Let's do this then, so that I can continue to see both of them. And there we go. All right, now it wants me to write another formula like this one. It says that currently the record, use R for record, and it's going to be for a particular year that I'm going to call T, is going to be, notice they're giving us the whole year here. It's going to be how many years have passed since uh, 1990 times a negative 0.07 seconds a year plus my original rate of 46.7. The other way that you could write that would be 46.7 minus 0.07 times T minus 1990. That's another way to write it. Or you could even multiply all that out and say that 0.07 times 1990 plus 46.7 is going to be the same as 186 minus 0.07 T. So you can do it like that. So plus negative, negative is positive, or t is the year. So just check that out. 186 minus 0.07 times the year 1990 should give me 46.7, which it does. All right. So I like this form. 186 minus 0.07t. What does the model predict about is going to happen in 2017? Let's see what it says is going to happen here. So that model, if I plug in 2017, 186 minus 0.07 times 2017, and it says that the record should now be 44.81 seconds. Cost of running the car is a flat $26 plus an additional 13 cents a mile. I'm going to use M for miles. I'm going to use C for cost. How far can you drive on $99? I disagree with the answer on the answer key, and I'm going to tell you why. So 99 minus 26 means you have $73 to spend on mileage. I'm going to divide that by 13 cents. So it says that I should be able to, and the answer key is going to tell you we'll round this to the nearest mile. No, don't do that. Think logically here. This is the most that I could afford with my money. I can't quite get to the 562nd mile. So my answer here should be that I can only go 561 miles if I'm measuring in whole miles. I could say I could go 561.5 miles if I could, if they're going to charge me per the half mile, but everything indicates here that they charge me per whole mile here. So I can't go to the 562nd mile because I can't afford that. I only have $99 to spend. Watch what happens if it's 562 times 13 cents a mile plus $26. Oh, I'm more than $99. See that? I can't afford it. So be careful. Rounding is not always, regular rounding rules are not always the right answer. Sometimes you've got to think critically, think logically, like we talked about in chapter 1. You can rent time on computers at a local copy center for a $7 setup charge plus an additional $4 for every 10 minutes. So, okay, for every 10-minute interval, let's say that is T. Hang on a second. So this is going to be, if it's $4 for 10 minutes, then it is 40 cents for 1 minute, right? So let's write it that way, where T is the number of minutes. So this is going to be 40 cents per minute, right? And this is going to be C of T, $7 plus 40 cents a minute. How much time can you rent for $24? Well, 24 minus 7 is going to be 17. I'm going to divide that by my 40 cents a minute. And I should be able to get 40, and it depends again here if you can be charged for half a minute or increments in less than 10 minutes. It's not very clear here, so there could be some different answers that would be right depending on how you interpreted this problem. One correct answer would be that you could get only 42 minutes if you're assuming you're charging by the minute. Since it says they're charging in 10-minute intervals, I'm going to assume here that I can only get 40 minutes, because as soon as I go over 40 minutes, I assume I'm going to get charged for the next 10 minutes with the way that the problem reads. Again, my answers are not going to match the answer key, but I'm reading the problem here that it says that you're being charged in 10-minute intervals, so I better give my answer in 10-minute intervals. Okay? Think critically. Again, you are going to get a multiple choice test, so you're going to see the right answer in front of you, and you're going to be able to explain why you picked the answer that you did. So, but it would also not be wrong to say 42 minutes here if you assume that you can get charged by the minute. If you assume that you can get charged by the half minute here, then it wouldn't be wrong to say 42 and a half. This is the answer that the answer key gave. I doubt that they're going to charge by the half minute. They're probably going to charge by the minute or by every 10 minutes, the way that their pricing system said. So think critically about it. Next one, you can purchase a motorcycle for $79.80 or lease it for a down payment of $573 plus $212 per month. I'm just going to use X to represent the number of months. And I'm going to call this C of X. And we want to find out when those two are going to be equal to each other, where they cross each other. So 79.80 minus 573 divided by 212 is going to tell me that my X here is going to be, and again, look, I can't get to the 35th month, right? I'm sorry, it asks how long you need to go before you're going to pay more. So I haven't quite paid more at the 34th month. So this is going to be 35 months. Let's see if I got that one right. 5 is 34 months. What did I do wrong there? Purchase the motorcycle, lease it. And the equation that describes the cost of the lease depends on time. How long can you lease the motorcycle before you've paid more than its purchase price? Let me just do it this way in the calculator. All right, this is actually easier to see. I'm going to put in this equation, 573. Dump this out. Plus 212x. I'm going to come out here to my table. I'll automatically generate the table. And I'm just going to look and see. I'm looking for this number here, 79.80. When is the first time that I've paid more than 79.80? There it is, 35 months. So oh, they're asking in a weird way. They're saying you don't want to pay more. So go back. They're saying this. They're saying you want the month before. I misread the question. Got it. There we go. So yeah. So you're saying you can go up to 34 months without paying more in the lease than buying outright. All right, that's right. The math club wants to pay a visitor $74 to speak at a fundraiser. The tickets will be sold for $5 each. Means that the profit that they're going to make is going to be $5 for each ticket minus the $74 they have to pay for the speaker. When will they break even? Once they've sold at least 15 tickets, because 14 tickets is only $60. 15 tickets is going to be $75. They'll have $1 in profit there. So they can only sell a whole number of tickets, so they need to sell 15 tickets. Add these two sales taxes together, state and local, to get a total of 8% sales tax. That means that the item that you're paying for is going to be 108% of its face value when you pay for it at the cash register. So it tells you to find the function T of P. The T is the output, P is the input, and you want 108% of P. Then they want to ask you, what does something that costs $49 before tax, what do you pay for it? So that's going to be 108% of $49 is going to be $52.92. Suppose that you were 24 inches long in birth and you were 4 feet tall at your 10th birthday. I'm going to tell you that they want to do everything in inches here. Change that to 48 inches because it's the smaller unit. Stay in the smaller unit here to be more accurate. So change in Y is going to be 24. Change in X is going to be 10 years. This is inches, this is years. So M is going to be 2.4 inches per year. We're going to start off being 24 inches long. So my height, H of T, is going to be 24 plus 2.4 inches per year times the number of years. So they say, what should your height be at age 9? So 24 plus 2.4 times 9 should be pretty close to age 10, right? That would be 48 there. This should be 45.6 inches. And at age 31, 24 plus 2.4 times 31 is going to give me 98.4 inches. That 98.4 inches seems like a lot until you divide it out and you see that person is 8 feet tall. So let's see if that's right. That's a pretty tall person, right? Assuming that they keep growing. 8. Yep. So we don't actually keep growing like that usually. So usually stop growing somewhere around age 18 to 20 something, you know. So, but if we did continue that pattern and if it was linear, that person would be over 8 feet tall when they hit age 31. Person's taking a 30-hour review class, to prepare for a standardized exam, have a score of 620. Persons with a 70-hour 791. So we're going to be looking for this slope, 791 minus 620 over the difference between 70 hour and 30 hour is going to be 169 over 40. Just make sure that that's right. 791 minus 1 minus 620 is 171. That didn't look right. I went the wrong way. Divide that by 40. It's going to be 4.275. So my function here is going to be, I'll call it T for test score of little t time spent studying is going to be let's figure out what the zero score is. So 4.275 times 30 is 128.25. So I need to subtract that off of this 620. It's the score for 30 hours. And my score they should get without any studying should be a 491.75, and I should be able to add 4.275 for every hour that they study. Very similar problem, they just changed the numbers slightly so that I couldn't use the formula that I just created. So I got to make formula again. 795 minus 620, 175 divided by 40. Again, this rate of change is 4.375 now. Let's go back and let's look at that with 30 hours again. It's going to be a 131.25. Take that away from my 620. This gives me a 488.75 that they're expected to get with no studying. So then we want to predict what's going to happen if they study for 54 hours. So 488.75 plus 4.375 times 54, and that should give me a score of 725. On the exam. Getting close to being done. It may not feel like it. I know this one has a lot more calculations than some of the other ones we've done recently. 1995, the United States recovered 20% of its municipal solid waste through recycling, up from 17% in 1990. So I'm gonna say that this was 1990. Let's see, is years since 1990 is going to be the what I want for my X, and it was at 17, and then years since 1990 was 15, or was 5 years. 5 years, and we're up to 20%, and I'm just writing the percentage. I'm not writing it as a decimal. So based on those two data points, create a linear equation for amount recycled based off of the time here. And it's going to start off at 17%. And then it's going to go up by, and then this is going to be 3/5, or 0.60 T, 0.6%, like that. So similar problem, different data points. So they tell us that this was again 17% in 1990, but now we are at 22% 5 years later. That changes that. So this is going to be, you can call it R. Oh, nope, it says let P percent. So this is supposed to be P. P is the percent that we're calculating. P of T is going to be 17% plus, and now this is going to be 5/5 is going to be 1. That's just going to be T, so we're going to add a whole percent each year. Predict what happens in 2003. Again, T is the number of years that have passed since 1990, so to get to 2000, we get 10 plus another 3. So we're finding P of 13. So we're going to add 13% to 17, and we get 30. So this is going to be 30%. Draw a graph. Terrible at drawing graphs, but I'm going to try. Tuition for community college is $300. Let's see, that is, these are 200s, so 300 is halfway between 200 and 400. It's right there, plus 125. So I'm just going to use the increments to my advantage here to say 4 times that is going to be 500. So if I go 1, 2, 3, 4, 5, I'm going to be here at 800. From 300 plus 500 is 800, and that took me 4 credit hours to get that. And I could again do that again if I wanted to. Let's go 2, 2, 4, 5, and another 1, 2, 3, 4, and then another 2, 4, 5, and 1, 2, 3, 4, and so on, and then 2, 4, 5, 1, 2, 3. I can't do anymore, but the line should look like that. Should be able to do that. And then what's the cost if they take 15 credit hours? So our function here for their cost is going to be $300 plus 125x. C of 15 is going to be 300 plus 125 times 15. We can guess over here that it's probably going to be about 2,200. Let's see if that's a good guess. I don't know how good my drawing skills are. 300 plus 125 times 15 is close. I said it was about 2,200, so 2175, right? So I can use the line to kind of project and approximate, but that's not as good as figuring out the answer with algebra and arithmetic. Okay, so we've got the depth of the snow. D is the depth. It's going to start at 63 inches. It's going to lose 2 inches a day. And so it's going to start at 63 inches. It's going to lose 2 inches a day. Let's see here. Lost 2 inches, and these are in increments of 2. So let's do 4 inches. It went down to 59. So down here for this day. And then it lost another 4 inches to go to 55 and so on. So it's on a downward trend like this. Again, I'm not super great at doing this without a straight edge, but it should roughly end right down here. Just, it should end in 31 days. If I remember the problem correctly, it should come down here and it should all go away. And I messed up the slope slightly, but I'm close. It should go away in 31 days because 31 times 2 is going to be 64. 63 minus 64 is practically 0. It should go away right before that, right? So I'm sorry. So 31 and a half days. Yeah. Right. 31 and a half days. So yeah, that's pretty close. I wanted to see, this is what I'm saying, if I'm not making any sense to you. $30 and 1/2. That's what I meant to say. 30 and a half days. That's how long it should take to have no snow left. See that? It crosses right there. 30 and a half days. It's really hard to get perfect lines here without a straight edge. And this is why we don't use the graphs necessarily to calculate things in real life. We do the calculations and we use our calculator. And we can put the pretty pictures up there for people to kind of imagine what's going up. Graphs don't prove it because they're only as good as your eyeballs and only as good as the people drawing the graphs. All right. See you for the next video.